Alrighty, I think we're live. Good. Good morning, outstanding students of C period and F period and G period. I don't get to do that morning thing with F and G usually. Good morning, outstanding students of physics. It is I, Dr. Smith. As promised, I am putting some information up for you so that you can solve the problem set, which is still due on Monday. I'm going to basically go through some problems very much like, exactly like the ones on the problem set. I apologize, the video is horrendously laggy. I'm new at this, bear with me. My teenager is off with a friend of his, and so I can't actually get the help that I need. I know you guys can do much better. Anyway, I'm learning, hang with me. Welcome to my house. This is known as the chalkboard room. I'm going to start off with a problem that is like 3B. It's not exactly the same because, well, then you wouldn't get the opportunity to do that problem, and we'd hate that. Problem like 3B. 3B reads an automobile is driven 30.0 miles north and 25.0 miles west, and you are to determine the distance and bearing by calculation for B as opposed to graphically. So what I've done is I've drawn my little compass rose, and I've got 000 marked, 180, 090, 270, so we're all set. And I've drawn a diagram with a car going 50.0 miles to the north. So I just drew the vector arrow in, and I labeled it 50.0 miles at 000 degrees. It's really important to label it when you're doing it analytically because you don't have to get very precise. I don't have actually my precision chalkboard drawing tools here because they're at school. I just drew this and said, okay, that's 50 miles. I didn't measure anything. And then for this one, this is going 10.0 miles to the west. So our car is going 50.0 miles north, 10.0 miles west. And I just drew that, and I kind of just swagged it. I was like, yeah, that's about 1/5 of that, and so it's good. And as long as you label it 10.0 miles at 270, it's fine because we're doing it analytically and we don't have to be super precise on our actual graph. So we need to solve for the resultant, which is, as always, from the point of origin here to the end of the last vector that we're adding. And so what I've done is I've drawn that resultant in, and then I labeled the angle theta because we want to have an angle in there, and we're now going to solve analytically, that is to say using trigonometry. So it's SOHCAHTOA. And so let's review what we have for SOHCAHTOA. We have the hypotenuse over here, right? So this is the hypotenuse of the right triangle. And then we have the opposite angle over here. So the opposite is equal to 10.0 miles. And then we have the adjacent side over here because that's adjacent to the angle, and that's equal to 50.0 miles. And so we need to solve for the hypotenuse and for the angle theta. So that's what we're doing analytically. So I'm going to use trig to do that, and I have to keep track of my trig function. So I have sine is opposite over hypotenuse, but I don't know theta, so sine and theta I don't know, and I don't know hypotenuse, so that's two variables that I don't know, so that's not going to work. But I can figure out what theta is because the tangent, remember, the tangent of theta is equal to SOHCAHTOA, TOA, that's the opposite, over the adjacent, and that's the tangent of theta. And so I can then write that the tangent of theta is equal to the opposite, which is 10.0 miles. So 10.0 miles divided by the adjacent, which is 50.0 miles. 50.0 miles. The miles cancel out, which they need to do because a tangent is a pure number, right? So I can't have units in there or I've done something wrong. So that's 10 over 50. You divide that out and you get that the tangent of theta is equal to 10.0 divided by 50.0, which is 0.2. Now, to the right number of significant figures, it's 200, but we're in the middle of a problem, so we don't need to worry about that so much. So that's the tangent of theta. To figure out what theta is, well, we don't need the tangent, we need the angle. And so to figure out the angle, we have to use the inverse function. We have to undo the tangent. And so we use a function called inverse tangent, or tan minus 1. So on your calculator, it says tan minus 1. It's like second tangent key or something like that. And it says tan minus 1, so you will use that on both sides, right? So we have to do this function. It's a mathematical function we have to apply to both sides of the equation. It's just like taking the square root of both sides of the equation. So the inverse tangent of the tangent, that just gets rid of the tangent. And so the inverse tangent of the tangent of just gives me theta. So I have theta over on this side is equal to the inverse tangent, that is to say the tangent minus 1 of 0.200. This really is the angle whose tangent is 0.200. That's what it means. And so what you need to do practically, though, is just punch it into your calculator. And so you just punch in inverse tangent. So I don't have my TI calculator, so I got to do it on my HP, which is different than the way you'll do it. But anyway, you take the inverse tangent of 0.200, inverse tangent. So I will press a little. Sometimes it's called arctangent or atan. I think on your calculators it says tan minus 1. And I get 11.3. Make sure you're in degree mode. If you didn't get 11.3, it's because you're not in degree mode. So that is, so I get theta equals 11.3 degrees. So yay, I have theta. I don't have the direction yet, because theta is this angle of a triangle. It's not a compass direction. So I still have to get that. And so to get the compass direction, what I need to do is say, all right, this is north, and theta is 11.3 degrees to the left of north. Right? So I've got 0, 0, 0, or 360, and then I've got 350, 340, 330, right? And so what I have to do is, for my direction, the direction that the car has gone is 360 degrees minus 11.3 degrees. And so that gives me 349 degrees. And so that is the direction of my resultant vectors, 349 degrees. Three significant figures. And since we're doing it analytically, we have to worry about the significant figures as they're given, as opposed to when we were doing it graphically, when there was measurement error from the graph. So in this case, I need those three significant figures, and that's my direction. Okay, so we now have the direction the car goes. We need to solve for the magnitude. You could just use the Pythagorean theorem. If you're happy doing that and you prefer Pythagorean theorem, which many people do, no problem. You've got, a squared plus b squared equals c squared. C is equal to the square root of, 10 squared plus 50 squared. No problem. I'm going to show you how to do it using trig, which is also, fine, and that's, another way to do it that is somewhat easier if the data is already in the calculator. So we know that the sine of theta is equal to the opposite over the hypotenuse. So the sine of theta is equal to the opposite over the hypotenuse. But we know what theta is now. And we know the opposite is 10.0 miles. And so I'm going to fill those in. I've got the sine of, and theta is 11.3 degrees. So the sine of 11.3 degrees is equal to the opposite, which is 10.0 miles, divided by the hypotenuse, which is what I'm trying to figure out. That is the magnitude of the vector. So I just punched the number to the calculator, sine of 11.3 degrees, and that is 0.196. Just a number, 0.196 equals 10.0 miles over the hypotenuse. And then I'm going to just solve for hypotenuse. So the hypotenuse equals 10.0 miles divided by 0.196. So I'll just divide that out. 10 divided by 1.196, and that gives me a hypotenuse of 50.99, but I have three significant figures, and so that has to round to 60.0. 60.0 miles. And it's really hard to write at the bottom of the chalkboard. Okay, so that's 50.99, but when I signify that, it's 60 miles. So try again, Smith. 50.99 would round. Did I do this wrong? Sorry, here I am, real time. It's just like in class, huh? Sine of 11.3 is 0.196. 0.196, so 10. 50. Okay, so that should be 51. That is incorrect. I've messed something up. Okay, so let's try this again. We have 0.2 inverse tangent. That's 11.3 degrees. That's correct. Okay. Sine of 11.3 is 0.196. Okay, and sine is the SOH, opposite over the hypotenuse. Okay, and so that is divided by 10, 50.99, which is 51.0. Ah, that's, okay. Somehow I turned that into 60. See how easy it is to make a mistake? I understand, I really do, trust me. All right, so that is 51.0 miles. All right, so for our problem going 50 miles north, 10 miles west, the resultant is 51.0 miles on a bearing of 349 degrees, and that is like problem 3B. All right, I think YouTube is only going to let me upload a video that is like 10 minutes, so I'm going to do the next problem on another one. I'll see you then. Sorry for the face plant.